Okay, let's look at the homework 2.8, 3.1, number 5. Right, so this is a ladder problem. Right, so we have to assign some variables to changing quantity. Right, so let's visualize. Let's visualize right triangle right here. Right, where here's right triangle. Right? So since the bottom of the ladder is pulled away at the rate of 2 feet per second, so this is changing. So I'm going to call this quantity x right here. Right? And then the quantity right here from the bottom of the house to the top of the ladder, I'm going to give y. Right? So by Pythagorean theorem, we have equation. So by Pythagorean theorem, we have, right, so x squared plus y squared is equal to 25 squared. So x squared plus y squared is equal to 25 squared. All right. Then what we're looking for is how fast is the top of the ladder moving. So we're looking at the rate of change of y with respect to time. So we are looking for dy over dt. Right? That's what we're looking for. Right? Then everything else should be given. Let's try to find that. Right, for part A, so the bottom of the ladder is 7 feet away from the house. All right, so that's x. So x is given to be 7, right? So that's 7 right here. Right, and also dx over dt. Right, so dx over dt is going to be, right? So since the bottom of the ladder is pulled away from the house at 2 feet per second, so here, so dx over dt is 2, right? Then we should be able to find y by using this Pythagorean theorem. So I'm going to actually solve for y. So here, y squared is equal to, by subtracting x squared from both of the equation, you get 25 squared minus x squared, right? So since we want y, and y is the distance, so it's never negative, so I'm going to just go ahead and take the square root of both sides. Y is equal to, right, square root of 25 squared minus x squared, right? Since y is going to be positive, so we don't have to worry about the negative sign. All right, so since y is going to be, so y is going to be square root of 25 squared minus x in this case for part A is 7, so 7 squared. All right, so I'm lazy, so I'm going to just do a calculator. So it's going to be a square root of 25 squared. So let's see, where is squared? So squared minus 7 squared, right? And I have to get rid of that. Let's see, delete. Right, delete. Right, so let's that. Right, so it came out to be 24. Right, so this is 24. All right, the rest is pretty simple. All right, so start with this equation. Let's take the derivative. with respect to time, so with respect to t, right? So derivative of x squared is 2x, but since we're taking a derivative with respect to t, not x, we have to multiply by dx over dt, right? Plus derivative of y squared is 2y, but again, it's a derivative with respect to t, so dy over dt is equal to, right? 25 squared is a constant, so if you take the derivative, it's going to be 0. Right? Then we're looking for dy over dt, so I'm going to just go ahead and simplify. So first step is divide it through by 2. That way we'll get x times dx over dt plus divide by 2 y dy over dt, and 0 divided by 2 is still 0, right? Then we can just subtract x times dx over dt, so that you will have y dy over dt is equal to negative x dx over dt, right? Then we can divide through by, we have to get rid of y, so divide through by y to isolate dy over dt is equal to negative x over y times dx over dt. Right, then we just plug in the known numbers, so it's negative. Right, x is given to be 7, so plug in 7 here. Right, y we found that to be 24, so 24 is there. Right, then dx over dt is given to be 2, so times 2. So we can simplify 2 and 24 cancel out, so that gives you 12 on the bottom. So it's going to be negative 7 over 12. All right, so let's type it in to make sure it's the right answer. All right. All right, similar way, and we want to type in, let's see, how fast is the top of the letter moving down? So we're going to put a positive value. So it was 7 over 12, right? So type in 7 over 12 feet per second. So let's check the answer. Submit for testing. Okay, it came back, and looks like we got part A correctly. And other parts are very similar, right? That's it. I hope that this was clear.